Hello, this is the review for the test on exponents, radicals, and rational or fractional exponents. So let's get started. Okay, so remember to always do the same steps we've always had for regular coefficient numbers. There's a lot of rules with exponents, but they do not apply to coefficients. So a 7 times -2 is still -14, right? And with variables, okay, there's a couple ways of doing this. We could just add them up, right, and do -5 plus 4, right? And -5 plus 4 is -1. And with negative exponents, remember those are positive fractions, right? So we're going to move this to the bottom, and it will be a positive 1 exponent. Right? So our final answer would just look like this. -14 over x would be the final answer there. Notice how we only move the x, not the 14, because this is a negative exponent, so it moves. A negative number does not move. It stays there. Let's go to number 2. Same thing, just 2 variables instead of 1. So still going to multiply regular coefficient numbers like we always have. -36. We'll have x to the 3 plus 8. And we'll have y to the 7 plus 15. So we have -36, x to the 11th, y to the 22nd. There we go. Number 3. Notice how we have a extra exponent out here, so we're going to simplify this part first and then combine it with this part. Okay, so first let's figure out what this is. We have negative, and we can write it out the long way if we like, which just means this, right? And times itself. Okay. That's what this means. And now we can figure out what all this means all together. So we're going to have now -5 times a -3 times a -3. So that is -45. We're going to have x to the 7th, x to the 4th, and x to the 4th. So 7 plus 4 plus 4 is 15. And then lastly, we're going to have y to the 3rd plus times y to the 3rd times y to the 3rd. So add those all up. 3 plus 3 plus 3 is 9. So we'll have -45 x to the 15th times y to the 9th. Let's go down to number 4 here. So now we have variables on the top and bottom. Remember, you can always show the work. Just a little side problem right now. You can always show the work if you're not sure. So if you have x to the 4th over x to the 2nd, you could always just put 4 x's on top and put 2 x's on bottom. See what cancels out. Alright, and you can see how many are left and if they're on the top and bottom. So there's 2 left over. So the answer is x squared, and it's going to be on the top, and there's nothing on the bottom. Okay, so there's always a way of showing the work a long way if we're not sure. Okay, there we go. So otherwise, let's just break it up into smaller pieces. I'm going to simplify this. Okay. So just reduce -8 over 14 like you have for years, and you'll divide top and bottom by 2 and get -4 over 7. You'll notice I put the negative on top. It's not that it matters. It just it's a preference. You can put it in the middle or you can put it on top. Okay. Next, I'm going to figure out what is this. Okay. So if you have 10 x's, remember if I go 1, 2, 3, 4, 10 on top and I do 5 on the bottom, how many will cross off and cancel out, and where would they be left over? So you can see if there's 10 on top and 5 on the bottom, these 5 will cancel out with 5 of these, right? And there'll be 5 less on the top, so you're going to have an x to the 5th on top. Okay? And we'll just repeat the process with the y's and the z's. Okay? So here you see there's 7 on top and there's 11 on the bottom. So these 7 will cancel out 7 of these on the bottom, so there'll be 7 less on the bottom. So we'll have 4 left over. So you have a y to the 4th on the bottom. Okay. And lastly, you see we have z to the 6th over z to the 6th. So if you wrote those all out, 6 z's on top and bottom, right? Every single one of them cancel out, so there's nothing left. So all we have is this for our final answer. The z's completely cancel out and equal 1. So there's no z's in our final answer. So think about when you have a lot going on, breaking up to smaller colors or parts like I did. Do the numbers, do one variable, figure out what that answer is, do the next variable, figure out what that part is, and then just put it all together in the end. Alright, so going back to some negative exponents. Alright, so we have a negative exponent. That means we're going to move it, or technically you're taking the reciprocal, which means you move from the top to the bottom or bottom to the top. Okay, so you can think of this as already being a fraction, and we're just moving any negative exponent, and we're going to move it. So we're going to have this to be x to the positive 5. Nothing else to do here. The 2 on the y is positive, so that doesn't move or anything. And the negative 3, that's just a regular number. So remember, don't move all negatives, just move negative exponents. Okay, so you can go through and just see ahead of time what part will move and what parts will stay put. Okay. And let's keep it going. So again, it'll break it up into smaller pieces. Okay, what is 12 over 15 reduced to? Divide top and bottom by 3. It's just 4 over 5. And again, the negative exponents are what move, right? So this negative exponent will move up here, and this negative exponent will move down here. Notice how the ones that are positive just stay. So the x to the 5th is going to stay there, and the bottom, the y to the 2nd, is going to stay there. But I'm going to move that x to the 3rd, negative 3rd, that's going to move to the top, be x to the positive 3. And then the y to the negative 8 is going to move to the bottom, be y to the positive 8. Okay. And then we can simplify. We have on top, we have x to the 5th, x to the 3rd, so altogether you have 8 x's. And on the bottom we have the 5. And we have 8 y's and 2 more y's, so we have 10 y's altogether. So again, breaking up into the coefficients and then one variable at a time. Okay. More negative exponents. So this means everything's to the negative 4 power, so everything moves. The 3 is going to move to the top, and the 2 will move to the bottom. Another word for that is the reciprocal. Right, so everything moves, and then we raise it to the 4th power. And again, if you're not sure how to do it because it's a fraction, just write it out the long way. Do 3 over 2 times 3 over 2 times 3 over 2 times 3 over 2. Right? So 3 times 3 times 3 times 3. Right? That's the same as 9 times 9. That's 81 on top. On the bottom, 2 times 2 times 2 times 2, which is the same as 4 times 4, which is 16. So even if it's a fraction, you can still do it. And leave your answer as a fraction. No decimal needed. Alright, so let's start doing roots. So remember, if there is no root given to you, it's automatically a square root. What times itself 2 times, right? Same thing times itself 2 times equals this, 36x to the 4th. So again, break it up. What times itself is 36? That'd be 6 times 6. And what times itself would be x to the 4th? That'd be 6. That'd be x squared. So our final answer would just be 6x squared. Okay. Number 9, very similar, just with a cube root. So a couple ways of doing these. You can break it up into smaller pieces and just do the number and each variable. Okay. You could write this as a 1/3 power, okay, because a cube root, which is a 3 here, is the same as a 1/3 power. So a couple ways of looking at it. So I'm going to look at it this way. I'm going to take the cube root of -27, right? Then, which is what, -3. What times itself 3 times is -27? That'd be -3 times -3 times -3. But with the exponents, if we looked on these before, it's the same as, remember this is a 1/3 power, and when you multiply 6 times 1/3, that's just the same as 6 divided by 3, which is 2. So recall that you just need to divide each of these by 3. And you notice that the exponents all are always going to be divisible. So like 6 and 15 both divide by 3 evenly. So we're just going to do 6 divided by 3 and get 2. And y, 15 divided by 3, and we'll get 5. Okay. Don't forget to also do the numbers, right? We still had to find the cube root of -27 here. All right, let's go on to page 2. Okay. So again, what times itself 3 times is 8. Okay, and you'll get, well, 2 times 2 times 2 is 8. What times itself 3 times is 125? 5 times 5 times 5. So our answer is just 2/5. And you can always just double check it and make sure it's accurate. Yeah, 2/5 times 2/5 times 2/5 does equal 8 on top and 125 on the bottom. Okay, so it's like the one we just did. So we're going to do, what is the 5th root of -32? Right, so what times itself 1, 2, 3, 4, 5 times equals -32, right? And we'll get -2. Then with the exponents we can just divide. So 10 divided by 5 is 2, and y, let's see, we have 25 divided by 5, which is 5. There we go. So if we multiply this right here 5 times by itself, we would end up with -32 x to the 10th, y to the 25th. Okay. So this has an exponent on the inside. There's a couple ways of doing this. I'm going to do both. You can pick the way you like. One way is to simplify the inside. So if we square the inside, right, that's going to be 64, 8 times 8, because I'm squaring 8. And that's going to be x to the 6th, 3 times 2, and then 12 times 2, and get y to the 24th. Then you can take the cube root of 64, right, and then divide each of the exponents. 6 divided by 3 and 24 divided by 3, which is the root, divided by 3. Each of these divided by 3. So what times itself 3 times is 64? You get 4. 4 times 4 times 4 is 64. And then 6 divided by 3 is 2. 24 divided by 3 is 8. Okay, so that's one way of doing this. Okay. Another way would be to do the cube root of just this part. So, and then square it at the very end. So we can do, yeah, cube root of 8, right? Then divide each of these by 3, right? And then at the very end, get that answer and then square it, So the cube root of 8 is 2. 3 divided by 3 is 1. 12 divided by 3 is 4. But then at the very end, you can square it, and you get the same thing. 2 times 2 is 4. 1 times 2 is 2, x to the second. And 4 times 2 is 8. So you can see you get the same answer either way. So you'll notice there are many ways of doing these problems. You can do either way. You don't have to do both, just one or the other. Okay, let's go down to 13. So we got some roots here. So remember that this is the same as a 1/4 power, or dividing by 4. So we can have on the top 20 divided by 4. I'm going to write out all these steps. 16 divided by 4. And on the bottom, same thing. We'll have 12 divided by 4 and 24 divided by 4. So we have, let's see here, x to the 5th, y to the 4th, and x to the 3rd, and y to the 8th. Right? But we can still simplify this more because there's x's on the top and bottom. So just remember, we could always write this out the long way. If you have 5 x's on top and 3 on the bottom, right, then 3 will cancel out, and you'll have 2 left on the top. So we have 2 x's left on the top. And then we could do the same thing here with the y's. 4 of these will cancel out with 4 on the bottom, right? So these 4 will cancel out, and there'll be 4 less y's on the bottom. So 8 minus 4 is just 4. So y to the 4 on the bottom, though. Okay. And there's your final answer. Okay. 14. Okay, so a couple ways of doing these again. We could square this out on the inside and then do the third root, but you can also do the third root and then square. It's completely up to you. Either way will work. Okay. So what I'm going to do is actually rewrite this with a fraction exponent. So I'm going to have 8x to the 6th, right, and squared, which is the same thing, but then I'm going to write this to the 1/3 power. Right? And again, the order doesn't matter when you're multiplying. So what I like to do is switch the order of the exponents. So keep that part the same, but I'm going to switch these two and make it to the 1/3 power, and then I'm going to square it. I just switch those two. So now I'm going to do the cube root of here, right? So cube root of 8 is 2. 6 divided by 3 is 2, right? Then I'm going to square it. So that's 2x squared times 2x squared, which is 4x to the 4th. That's one way of doing these. Okay. Another is just to actually square it out. But you can see you can get some big numbers, so that's why I tend to shy away from it. If we square this out, we get 16 times 16, which is 256. Then we have to figure out the 4th root of that is, which is kind of a big number unless you have a calculator. So I'm going to do the same thing that I did before. Keep this the same. Right? Write it to the 1/4 power, and then switch these two outside exponents. So we have 16 x to the 12th. Right, but then I'm going to write it as to the 1/4 power, and then I'm going to square it. Okay, so we have, okay, what is the 4th root of 16? What times itself 4 times is 16, and you'll get 2. And then 12 divided by 4, you get 3. And that can square, so I'll have, once again, 2 times 2, and then here it's multiply the exponents, 6. And then lastly, we still have to multiply these both together. So 4 times 4 is 16. And then x to the 4th times x to the 6th. There's 4 x's here, 6 x's here. So we have 10 altogether. 16x to the 10th. Okay. Now let's start off with some fractional rational exponents, and then if you like, you can just get the answer from here, right, and say, well, I know the answer is 2, but you can also rewrite this as a square root if you like. So what's the square root of 4? And that equals 2 as well. So if you want to convert it to a root form and then answer, or if you can just go straight from the rational fractional exponent and answer, that's fine as well. Okay, let's go down to 16. So we have the third root of 8. So what times itself 3 times is 8? Notice how there's a negative here. That's just going to remain out there. So we're really just focusing on this part right here. And then we'll have a negative in front of that answer. So third root of 8, what times itself 3 times equals 8? And you'll end up with 2. Third root of 8 is 2. So since we have a negative in front, we'll have negative 2 as the final answer. 17, we have a couple square roots because it's a half power. Remember, half power means square root. So square root of 9 is just 3. And square root of 25 is 5. So it's just asking really, what's 3 minus 5? And you'll get negative 2. Okay, number 18. Go ahead and do the parentheses first. Inside the parentheses, what's the square root of 16, or 16 to the 1/2? And you'll get 4. Bring down the 3 on the outside, and 4 to the 3rd power. 4 times 4 times 4 is 64. Final answer. Okay. So the next page, go to number 19. Okay, so we see you have a number on the top and the bottom. We're going to rewrite this the same way we did on 18. Okay, it was already broken up for us on 18, but I'm going to rewrite 3 over 2 as 1/2, and then times 3. So I just really took the numerator, the top number, and brought it out. Okay, made that a 1. So I'll do the 25 to the 1/2, or square root of 25, and get 5. And then lastly, raise it to the 3rd power and get 125. 5 times 5 times 5. So anytime you have different numbers on the top and bottom, we can always just break it up into 2 parts. So let's practice that a few more times. So we're going to look at this as 64, the cube root of 64, right, to the 1/3 power, and then square it. So what times itself 3 times is 64, and you'll get 4, and then go ahead and square that, and get 16. Okay, same idea with variables, so we'll have 27x to the 6th. I'm going to raise that to the 1/3, and then square the answer. Okay, so we have cube root of 27 is 3. 6 divided by 3 is 2, and then take that answer and square it. So 3x squared times 3x squared. 3 times 3 is 9. X to the 2nd times x to the 2nd is x to the 4th. And don't forget, we can always just write that out a long way if we have to. 3x squared times 3x squared. 3 times 3 is 9. And then 1, 2, 3, 4 x's. That's why it's x to the 4th, in case you need to check it out. And let's go to 22. Okay, so now we have 3 parts. We have a negative, we have a root, and then we have and exponents. So there's really three different things going on. And you can do them in any order that you like that's convenient. So there's different ways of looking at this. So we could do 4 to the negative 1, right? That's the negative part. And then do the 1/2, okay, the square root there. Okay? And then do the 5th power. So just showing you that this negative 5/2 is really three different steps. You have to do the negative step, the bottom number step, and the top number step. There's three different steps here. Okay? Of course, we can switch the order on any of these you like. So if you want to do the negative last, that's fine as well. So the order is not important. Okay, but there's probably one that's easier than the other. So I'm going to stick to this order. I'm going to do 4 to the negative 1. So that equals 1/4. That makes it a fraction. Right? And I still need to raise it to the 1/2. And I still need to take it to the 5th power. So square root of 1/4 is 1/2. Right? Raise that to the 5th power, that's 1/32. Okay? Now let's say you're not liking these fractions. So the fraction part comes from the negative exponent. So you could rewrite this and do the 1/2 first, okay? Then do the 5th power, and then do the negative 1 at the end. So you see the order is not necessarily locked in place. So we could do square root of 4 and get 2, raise it to the 5th power and get 32, and then at the very end raise 32 to the negative 1, makes it a fraction, and you get 1/32. Okay? So notice how it's the same thing no matter what order you go in. Sometimes there's one that's easier than others, other times it's just a personal preference. Okay, so now we're going to start combining all these rules all together at once. So we have to be very careful, watch out for details. Okay. So let's first take care of this part, figure out what this is. So remember, if you need to, you could write this out the long way. That's x to the 3rd, y to the 4th, times itself 3 times. X to the 3rd, y to the 4th, times x to the 3rd, y to the 4th. Right? And you could even say this is x times x times x, y times y times y times y. And you could do that 3 more times, just so you can count up and see how many variables there are. Okay? What you end up with is that it's the same as multiplying these exponents. So we're going to have 3 times 3, which is 9, 4 times 3, which is 12. Okay? And you can verify that if you like. Okay? Next we have roots here, so we're going to be dividing. Right? So we have 12 divided by 3, which is 4, and 6 divided by 3, which is 2. And again, we can just add these up. 9 and 4, 9x is here, 4x is here. Altogether you have 13x's. And 12y is there, and 2y is there. You have 14y's altogether. Alright, keep going. Okay, we got to do some square roots, but of course, order of operations, if you can simplify the parentheses first, let's do that. So, if you like, we can make this over 1. So we have 6 x's on top, we have 8 on the bottom. So these 6 will cancel out 6 of these. So these will cancel out 6 of these, so we have 6 fewer x's on the bottom, so we'll be left with 2. Right? And also look at the numbers. Can those be reduced? And it doesn't look like they can, so let's find the square root now. The 1/2 power. So what times itself is 9, right? I'm just doing the top and then the bottom. What times itself is 9? You're going to get 3 times 3, so we got 3 on top. And what times itself is 16? You get 4. And what times itself is x squared? And you get x. Right? So notice again, I just do piece by piece, one by one. Right? If you like, you can also just think, what times itself 2 times equals 9x 16 squared, and again you get 3's on top, 4's on bottom with the x's. So that's why our answer is 3 over 4x. Let's go to do a little bit of solving here. Okay. Solve graphically. So I want to start with 0 on these and go up. Okay. So just be careful though, because this means right here you have to do the exponent first and then take that answer and multiply it by 3. Okay. Don't multiply the 3 times 3 and then do the exponents. Order of operations. Exponents first, then multiply. So with 0, it's going to be 3 to the 0, right? Which is 1 times 3. So we get 3. And then 3 to the 1, which is 3, and then times 3, 9. And then 3 to the second, 9, times 3, 27. And then this will just keep on going. And so we'll have, let's see, 27 times 3, 81. And we'll have 81 times 3, which is 243. And that's probably as high as we need to go because we're getting some big numbers here. And on this side, we'll just have the same thing because y equals 27, which means that's the answer for each one. So that's a horizontal line. Okay. So yeah, we probably don't need these last two. And the point is we're trying to see where they will intersect. So I kind of know to stop because I can see that, yeah, 227, that's where they're going to be intersecting. So otherwise I would have kept on going to see when that happened. Okay, so let's go ahead and graph this now to the right. Okay, I'm going to space this out a little bit. So let's do 1, 2, 3, that'll be 4. Okay, so I know the intersection happens at 2. And then I need to count up to like 243. So maybe I'll just go only go up to 81 here just to keep it a little easier. So yeah, let me count by 10s and go up to and stop at 81. Otherwise the graph will be too cramped. So I'm going to go here, start counting by 10s. So we have 10, 20, 30, all the way. And then let's go ahead and graph them both. So the 27 is going to be roughly right here. There's 27, horizontal line. Right, and then check your table one more time. So we have 0, 3. 0, 3. We have 1, 9. 1, 9 right about there. We have 2, 27. We already know that's where they intersect. So that'll be right here. And we have 3, 81. So 381 will be right about here. And our 4 will be 243, which would be way up here off our graph. It would be really, really high. Okay, so I just want to connect this as smooth as possible. And just kind of keep that going up at a nice angle. Something like that. And again, the main focus is on where it intersects, which you already know from the table because they have the same numbers on both. So we better get the same answer. When we solve, we better get x equals 2 because that's where they intersect. So we already know if we've done everything right so far, when we solve this algebraically, we should get the same thing. So let's first divide by 3. Remember, with solving, you do everything in reverse. So we have exponents of multiplication. So we'll do the multiplication first by dividing. So 3 to the what power equals 9. And I like writing it out both with the same base. So we can see same bases, therefore the exponents are equal to each other. So sure enough, we got 2, just like we did on our graph, they intersect at 2. And just like we did on our table, we got 2. So all 3 of these should agree with one another. Okay? All get the same answer no matter what, off a table, a graph, or solving algebraically. Okay, let's do a few more just to solve the equation. So as I just mentioned, I like writing these so the bases are the same. So 3 to the x will be 3 to what power to get 81? That's 3 to the 4th. So bases are the same, therefore the exponents are equal. Okay, and it does say to check, so you can always check and just make sure. Yeah, 3 to the 4th, does that equal 81? Yes, 81 equals 81, so you're good. Okay, 27, again, do the dividing first, so let's divide by 3, both sides. So 4 to what power equals 16, and rewrite 16 with a base of 4, so 16 is 4 to the 2nd, therefore the base is the same, the exponents are the same. You get x to the 2nd, and we can check this. Do 3 times 4 squared, and make sure that's 48. Okay, so we get 3 times 16, and that is 48. Okay, number 28. Let's take care of the subtraction first by adding. So we have 3 to the x equals 19 plus 8, which is 27. So 3 to what power equals 27, and you get 3. So x equals 3. And you can do the check for that. Here we go, we got addition, so let's subtract. Okay, so we have 5 times 2 to the x equals 80, and then divide by 5, both sides. Okay, so 2 to the x equals 80 divided by 5, which is 16. And now 16 is 2 to the 4th. So, you know, x equals 4. And you can do the check for that. Okay, we got a minus 5, so let's go ahead and add 5. So 1/3 times 3 to the x equals 27. And we have multiplied by the reciprocal here, so multiply by 3 over 1 to cancel out the 1/3. So we have 3 to the what equals 27 times 3, which is 81. And then 81 is write it as an exponent, so that's 3 to the 4th power. So x equals 4. Alright, one more. I believe. 31. Alright, looks like we lost 31, so we can just go to 32. Okay, so we had an entire homework about these, where we just had to learn a pattern where we had a starting amount, okay, in function form and how much it's expanding by or multiplying by each time. So we made a bunch of charts, but in the end it just came out to something like this. Okay? And we usually give you what function to use. So we'll start off with that and find out what we're starting at. So in this case we're starting with 20 members. That's going to be the first number. Right? Then we're going to have the parentheses. The parentheses are how much it's expanding by. So it tells you that we're going to complement 3 students, right? Right here, complement 3 students, right? So each time complement 3 students. So whatever we're expanding by, that's what we are going to put inside the parentheses. So we have a starting amount and then how much each of those students are going to complement. So that's how we form those equations. Just remember that the variable is always going to be in the exponent. That's the whole idea here, to have variables in the exponents. Okay, so next we can just plug in 4 and see what we get. So 4 is going to be 20 times 3 to the 4th power. Okay, so that's going to be 20 times 3 to the 4th, which is 81. Which equals 1,600, and let's see here, that would be 80, that's in my head, 82, I think that's right. Alright, check down the calculator, close, it's going to be 162, 0, there we go. Okay, and let's put, so we're talking about students, let's put students in. There we go. Alright, let's do 33. Okay, very similar. What are we starting with? Okay, so it gives us p to the n, tells us to use p to the n here. We're starting with 192 players, and then each round, remember last time it was expanding by 3, but now it's half. So the number inside the parentheses is half. And then again, our variable is the exponent. Okay. So we can estimate this for 3 rounds. So basically we're going to take half 3 times, right? Because it cuts in half each time. So take 192, and we're going to cut in half 3 times. So half times a half times a half is 1/8, right? Which is just the same as, how did I get 8 here? Oh, that's fine. That should be a 2 from above. Okay. And then 192 divided by 8, right? 192 times 8 times 1/8, same as 192 divided by 8, and we get an answer of 24. We have 24 players remaining after 3 rounds. All right. Lastly, let's do some root estimating. So what you want to do is find the closest perfect roots that are close to the number inside. So we don't know the square root of 20, right? It's not a perfect square, so we have to do some estimating. The 2 closest square roots to 20 that we do know are square root of 16, right? We know that's equal to 4, right? And then something bigger than 20 that we know the square root of is 25. That's the square root of 5. So since the square root of 20, right, that's in between here somewhere, square root of 20. So I know the answer that I'm going to estimate is going to be about 4 point something. Okay? And ask yourself, is the 20, is that closer to 16? Is that closer to 25? And it's pretty much right in the middle, right? It's 4 away from 16 and 5 away from 25. So since it's 20 is in the middle of 60 and 25, I'm going to call that 4.5 because 4.5 is in the middle of 4 and 5. So it's about 4.5. And then we can do the same thing for 35. It's just that it's perfect cubes. Now, if you don't know your perfect cubes well, it might help to write those out. That 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, and 5 cubed is 125. So these are all the perfect cubes. We don't know those as well as perfect squares. And then we can see that 100 is right in here, between the cube root of 64 and the cube root of 65. So, yeah, cube root of 64 equals 4, and the cube root of 125 equals 5, and I know that cube root of 100 is right in there, between 64 and 25. Now, in this case, 100 is a little bit closer to 125 than it is to 64. Right? These are 36 away. These are only 25 away. So it's a little closer to the 5 than it is the 4. So I'm going to estimate that at around 4.6 or 4.7. Okay? It's only an estimation, so it doesn't have to be perfect. Okay? That's how we can use what we already know with perfect cubes and estimate what any perfect cube could be by seeing how close it is to something we already know the perfect cube of. Okay. Alright, so that concludes our review. Now remember, your goal is to be able to do this entire review by yourself with no help. So don't just write down the answers and say you're done. Make sure you could take a blank paper, blank review, and do this whole thing all by yourself with no help and get all the right answers, and then you'll know you're ready for the test. Okay? Act as if you're going to get this exact review as your test, and you'll be ready to go. Okay? Good luck.